Ladies and gentlemen, good afternoon. Thank you for being here. Before I will tell you and inform you what our company does and why we do it, I first would like to briefly introduce our company. Since 1967, we are developing and supplying process computers for greenhouses and indoor farms. Actually, our founder, Mr. Hoogendoorn, invented the world's first process computer, so-called IoT system for these facilities. So we have two divisions. One is focusing on horticultural automation and one is focusing on industrial automation. So Coca-Cola, Nestle, Heineken, they are our customers. But I am representing the horticultural automation division. We are active in more than 90 countries in the world. And I am based in Kuala Lumpur in Malaysia, and I'm taking care of all projects in Asia. So why are we making IoT solutions, process computer systems for greenhouses and indoor facilities? Well, as you know, the global population is rising, growing up to 10 billion people in 2050. And as we are continuing like this, by 2050 we will need 3 times planet Earth to feed our population, to cope with the demand. Water, fertilizers, minerals, everything will get scarcer, including land. So in this graph you will see an example of, for instance, how much water you will need to produce 1 kilogram of tomato. And as you can see in this graph at the left side, in open field, you will need 100 liters approximately to produce 1 kilo of tomato. So especially in Malaysia, where I live, you see large open fields for production growing, right? Including tomatoes. But you can do it in a far more smarter way. As long as you apply more technology, for instance, that you precision dose the amount of water, fertilizers, that you recirculate your water and reuse your fertilizers, you can save a lot of water. And as you can see on the right and the far right side, enclosed greenhouses, so these are environmentally closed, totally closed greenhouses in which you can control climate and irrigation, reuse water, reuse CO2, reuse also heat, radiation. You can optimize your crop growth and save a lot of water, up to approximately 5 liters for 1 kilo of tomato. So what our systems actually do is to produce more yield with less resources. And as you can see, and as you know, here in Singapore, there's a great need for that, and also there are big incentives for that. So that is why our company would like to contribute to this, to indoor growing in city facilities, rooftop greenhouses, container systems. Our systems can be applied in all these facilities. So I would like to show you a short movie to introduce our system.
The smartest way to analyze and control your growing environment. No matter a greenhouse or indoor farm, one or multiple locations, you are always connected to your crops. The beating heart of the system is the main control unit, taking care of climate, water, energy, and data management. It's connected to all sensors, hardware, smart cameras, and robotics inside your growing environment. This data is analyzed real time and can be combined with external resources such as weather data and letsgrow.com. IVO gives you insights on how your crops are performing, but can also act as a growth coach, give advice. Or you can choose to let the system operate autonomously. IVO is connected to a secured cloud environment, so all data is stored online safely. Backups make sure you will never lose valuable information, and you are always running the latest software. The system is very easy to operate, using a comfortable dual-screen setup. or controlled and monitored remotely on a mobile device of your preference. IVO is secure, HortiQ, ISO 27001, and ISO 9001 certified. It uses growth strategies and enables intelligent and data-driven growing. Due to its crop-specific approach, it always gets the most out of your crops while using as less resources as possible. Ready, set, grow.
So basically what our process computers do is they are the brain of a greenhouse or indoor facility. Our computers help to realize a stable climate in order to let the crop grow as optimum as possible. And in our software, in our algorithms, plant is the central focus of everything. So basically what our software does is irrigate water, irrigate minerals, forming a balance between different sources of radiation, like natural radiation, but also, for instance, assimilation lighting, LED lighting or Zonk lighting. So by controlling all these elements, it creates a stable and ideal climate, provided that the facility itself, the greenhouse and indoor farm, is suitable for it. So what we know is that to create an optimal plant growth, 3 balances are important. These are the energy balance, water balance, and assimilate balance. The energy balance is, for instance, the input of radiation, whether it's natural or by assimilation lighting, and the reflection of energy of a plant. So the water input that you give to a plant by irrigation, and the water output by evaporation of a plant. And the assimilate balance, finally, that is the forming of glucose, input of CO2, for instance, and the forming of glucose. And the stomata of a plant, these are small holes inside the plant leaf, they are essential. And if you can steer on stomata activity, then you can also know exactly how the plant is behaving, and you can steer on plant activity. So how do we know whether a plant is growing optimally or not? We use sensors for that. So for instance, not only temperature and humidity sensors, standard sensors, but for instance also camera images that measure plant temperature. You can see it here. And what is also important, for instance, PAR light, that is the photosynthetic active radiation that the plant takes up for producing the light that is important for plant growth. So another sensor is this plant temperature sensor, with which it is possible to measure plant activity. And we measure that according to the evaporation energy. From the plant evaporation, we can see how a plant is behaving, whether it's in stress or not. So what we do actually is, based on the measurements of these sensors, we can tell what we need to do, or actually the computer automatically calculates what it needs to do. So for instance, at nighttime, when there is a lack of radiation and there is not enough plant activity, the computer automatically notices that because of the plant temperature camera, or by a Pyrgeo sensor, as we call it here, whether the plant is in stress or not, whether the stomata of the plant leaves are closing. And then the computer automatically, for instance, activates the humidification or air recirculation equipment to enhance plant activity. But at daytime, here, when it could be that the evaporation is too high, the evaporation energy here, because of a surplus of radiation, for instance. And then the computer automatically calculates that it needs to close down the shading screen, for instance. It automatically does that. A computer calculates how much the screen will have to close based on a number of watts that is taken in by the plant. So it's a combination of measurements, radiation sensor, plant temperature camera, plant temperature sensor, with which the computer automatically steers plant behavior, basically. And it does that proactive. If you do that by hand, manually, or by observations, then you're mostly too late already. Yeah. So that is what we call data-driven growing. We look at data rather than subjective observations by people going into a facility and see that the plant is in stress. Then most of the time you're already too late. The computer is never too late because it's based itself on measurements, objective measurements. So our algorithms and our software is not asking itself the question, what has happened? We are asking ourselves the question, what is the best thing that could happen? And we help growers to optimize the growth in their facilities. And about these basic principles of plant growing and how to optimize plant growth, we have written a book which is called the Plant Empowerment Book. You can go to the website www.plantempowerment.com and you can order this book. It's very worthwhile. It describes the basic plant principles and how you can basically manipulate a plant in order to grow well. So I would like to conclude with some projects that we are doing, not only in Malaysia but worldwide. This is, for instance, a tulip growing project, vertical farming in the Netherlands. It's a hybrid project. It uses vertical growing installations together with a glass greenhouse. These are indoor facilities in the USA that we control. For instance, the lighting here, sun-T lighting, and irrigation. Sun-T is natrium lighting. Yeah. And here are facilities, closed environmental agriculture, so closed greenhouses projects in Malaysia, in Cameron Highlands, but also in lowland production, in which they grow leafy greens in ponds. But this is a glass greenhouse in Japan. This is a semi-closed greenhouse system in Korea, which a semi-closed greenhouse is some sort of environment that is totally isolated from the outside environment with only some equipment that can influence this isolated environment. So you can reuse all your resources, all your inputs, basically. It's a high-tech farm. Also research facilities, the Wageningen University uses our process computers, Vineland Research in Canada, rooftop growing, we are involved here. And also we are involved in projects that make use of solar energy by solar foil. Yeah, you can see. This is a project in Japan. So with this, I would like to conclude my presentation. Thank you so much for your attention, and I hope to see you next time. Thank you.